So the next topic is to find the particular integral of f of d into y is equal to q of x, where q of x is equal to x power m into v. This is the multiplication of the functions x power m into v, where m is a positive integer and v is a function of x. So to find particular integral of 1 by f of d into x power m into v, the function of x v can take three forms. One is e power ax, x power m, and cos ax or sin ax. If it takes the form v is equal to e power ax, then our particular integral becomes, we have to find particular integral for x power m into e power ax, which is in the form of e power ax into v. Means the differential equation takes the form f of d into y is equal to e power ax into v, which can be solved in the methods we have discussed previously. If v is equal to x power n, then particular integral becomes x power m into x power n, which becomes x power m plus n. For this function, particular integral can be found by using the binomial expansion, which we have discussed in the previous classes. If v is equal to cos ax or sin ax, then particular integral is equal to x power m into cos ax or x power m into sin x. So we are considering about only the condition where v can be cos ax or sin ax. In both the conditions, we know the procedure. Means e power ax and x power n, we know the procedure how to solve the particular integral. So now we are concentrating only on the conditions where v is a function of cos ax or sin ax. So we know that e power iax is nothing but cos ax plus I sin ax is the basic trigonometric formula in terms of exponential formula. So here cos ax can be real part of e power iax and sin ax can be imaginary part of e power iax. So clearly we can see that cos ax is the real part of e power ax and sin ax is nothing but real imaginary part of e power iax. Now, the particular integral of 1 by f of d into x power m cos ax becomes real part of 1 by f of d into x power m e power iax. Means the same procedure which we have done for e power ax into v, we have to do here. And we have to collect only the real part of the solution. Then we get the particular integral of 1 by f of d into x power m cos ax. Similarly, particular integral of 1 by f of d x power m sin ax is equal to imaginary part of 1 by f of d into x power m into e power iax. So similarly, here also we have to find the solution for x power m into e power iax, which is in the form of e power ax into v, and collect the imaginary part to get the solution for, or to get the particular integral for 1 by f of d into x power m into sin ax. First problem, solve d square plus 4 into y is equal to x sin x. So the given differential equation is d square plus 4 into y is equal to x into sin x. So already we know the solution is y is equal to complementary function plus particular integral. Put it as equation A. To find complementary function, the auxiliary equation is f of m is equal to 0, which implies m square plus 4 is equal to 0, implies m is equal to plus or minus 2i. Since the roots are imaginary, the solution becomes complementary function is equal to e power 0x. Since the real part is 0 here, 0x into c1 cos 2x plus c2 sin 2x, which is equal to c1 cos 2x plus c2 sin 2x. Put it as equation number 1. Now, to find particular integral is equal to 1 by f of d into q of x, which is equal to 1 by d square plus 4 into x sin x. So as we have discussed in the previous one, so e power iax is equal to cos ax plus I sin ax. Then e power ix becomes cos x plus I sin x. So here I am replacing this one as imaginary part of 1 by d square plus 4 into x into e power ix. So this is nothing but imaginary part of 1 by d square plus 4 into e power ix into x. Now this is in the form of e power ax into v. We can solve this by substituting in the place of d by d plus d. So here, since a is equal to I, here put d is equal to d plus I. So this is equal to imaginary part of, already we discussed that exponential should come to the left of the equation and d should be substituted with d plus I. So e power ix into 1 by d plus I whole square plus 4 into x is equal to imaginary part of e power ix into 1 by d square plus 2di plus I square plus 4 into x. We know that I square value is equal to 1. So this is equal to imaginary part of e power ix into 1 by d square plus 2di plus 3 into x. Now it took the form of x power m. So we know how to solve this procedure. First of all, take the constant outside. So this is equal to imaginary part of e power ix into 1 by, take your constant 3 outside. So it takes the form 1 plus d square plus 2di by 3 into x. So this is equal to imaginary part of e power ix into, this term comes to the numerator, ex by 3 into 1 plus d square plus 2di by 3 whole inverse into x. So I integral part of e power ix by 3 into 1 plus d square plus 2di by 3 whole inverse into x. Now this is in the form of 1 plus d whole inverse, which can be written as 1 minus d plus d square minus dq plus and so on. So this is equal to imaginary part of e power ix by 3 into 1 minus d square plus 2di by 3 plus d square plus 2di by 3 whole square plus and so on into x. So since the power of x is 1 here, you have to neglect higher order derivatives from d square. Neglecting higher order derivatives from d square. So after expanding this, we get only integral part of e power ix by 3 into 1. Here d square by 3 cannot be included because it is higher order power. So next term is minus 2di by 3 plus d square. All the terms are higher order terms only. Before writing this term, please be careful so that all the terms of derivatives are to be included. Otherwise, your answer may go wrong into x. So this is equal to integral part of e power ix by 3 into, now multiply your x inside, x minus 2i by 3 into derivative of x. So already we know derivative of x is equal to 1. So this is equal to integral part of e power ix by 3 into x minus 2I by 3. So after getting this final solution, you have to get only the integral part from this solution, which can be written as integral part of 1 by 3 into. Now again replace your e power ix as cos x plus I sin x, cos x plus I sin x into x minus 2 by 3 into I. Now collect only the imaginary part from this solution. If you multiply cos x and x, you get only real part, so don't take this. Now cos x into minus 2 by 3 into I, this will be the imaginary part. So take this term, minus 2 by 3 into cos x. Next, plus I sin x into x. This will also take the imaginary part. So plus x sin x and minus plus I sin x minus 2 by 3 I. This becomes I into I becomes I square, which can be replaced as minus 1. So it comes under real part. So before writing the solution, please be careful. Only you have to collect only the imaginary part. We are not concerned about our real part. So therefore, the solution will be equal to, particular integral will be equal to minus 1 by 3 into x sin x minus 2 by 3 cos x. This is our particular integral 2. Therefore, substituting 1 and 2 in A implies y is equal to c1 cos 2x plus c2 sin 2x plus 1 by 3 into x sin x minus 2 by 3 cos x. Next problem, solve d square plus 1 into y is equal to x cos x. So the given differential equation is d square plus 1 into y is equal to x cos x. So the solution is given by, the solution is y is equal to complementary function plus particular integral. To find complementary function, the auxiliary equation is f of m is equal to 0, which implies m squared plus 1 is equal to 0. By solving this, we get m is equal to plus or minus I. The roots are imaginary. Here. Therefore, complementary function is equal to e power 0x into c1 cos x plus c2 sin x. So this is equal to c1 cos x plus c2 sin x. Put it as equation number 1. Next, to find particular integral. Now particular integral is equal to 1 by f of d into q of x, which is equal to 1 by d square plus 1 into x cos x. So already we discussed that this will be equal to real part of 1 by d square plus 1 into x into e power ix. So this is in the form of, now this is in the form of e power ax into v. This is in the form of e power ax into v. So we can solve this by substituting in the place of d by d plus a. So since a is equal to I in this problem, put d is equal to d plus I. So this is equal to real part of, so e power ix should come to the left side of 1 by f of d, which is equal to e power ix into 1 by d plus I whole square plus 1 into x, which is equal to real part of e power ix into 1 by d square plus 2di plus I square plus 1 into x. So this is equal to real part of e power ix into 1 by d square plus 2di minus 1 plus 1 into x, since I square is equal to minus 1. So this is equal to real part of e power ix into 1 by d square plus 2di into x. So here the least term is 2di. So bring the 2di outside. So it will be equal to real part of e power ix into 1 by 2di should be brought outside. So it will take the form 1 plus d square by 2di into x. So here real part of e power ix by 1 by 2di into 1 plus d square by 2di into x. So this is equal to real part of e power ix by 2di into 1 plus, here d and d square and d gets cancelled. So it becomes d by 2i. d by 2i whole inverse into x. So it is in the form of 1 plus d whole inverse. So it is equal to real part of e power ix by 2di into 1 minus d by 2i plus d by 2i whole square minus so on into x. So since x has the power 1, neglecting higher order derivatives from d square, it takes the form, this is equal to real part of e power ix by 2di into 1 minus d by 2i into x. So this is equal to real part of, put your e power ix inside and multiply with 1 by 2di inside. So it will be 1 by 2di minus d by 2i into 1 by 2di into x. So here d gets cancelled. So this is equal to real part of e power ix into 1 by 2di minus 1 by 2 into I square into x equal to real part of e power ix into 1 by 2di plus 1 by 2, because I square value is minus 1, here minus to minus 1 becomes plus 1. So real part of e power ix into 1 by 2di plus 1 by 2 into x. Now multiply your x inside. So this will be equal to real part of e power ix into 1 by 2i into d into x plus x by 2. So since we know that d is a differential operator, 1 by d will be the integrating operator. So this will be equal to real part of e power ix into 1 by 2i into integral of x dx plus x by 2. So since d is there, 1 by d is there, we have to do integration, not differentiation. So this is equal to real part of e power ix into 1 by 2i into x square by 2 plus x by 2. So this is equal to real part of e power ix into x square by 4i plus x by 2. Until and unless this part is simplified, don't take the real part. After all the simplification only, we have to collect the real part. So this is nothing but real part of, now replace your e power ix with cos x plus I sin x to get only the real part. E power x cos x plus I sin x into x square by 4i plus x by 2. Now here 1 by I, another formula we are using, 1 by I is nothing but minus I. So if we take this, this will be equal to real part of cos x plus I sin x into minus x square I by 4 plus x by 2. So that we can collect easily our real part. So this is equal to, if we substitute cos x into, if we multiply cos x into minus x square by 4, we get imaginary part. So don't take that. Now cos x into x by 2 means x by 2 cos x. Next, plus I sin x minus x square by 4 into I. So I and I becomes I square. I square produces minus 1. So minus into minus here becomes plus x square by 4 into sin x. And this term I sin x plus x by 2 does not come because it comes under imaginary part. So this is our particular integral after collecting only the real part from the obtained solution. So therefore, substitute 1 and 2 in A. So therefore, y is equal to C1 cos x plus C2 sin x plus x by 2 cos x plus x square by 4 sin x. So this gives the solution of the given differential equation. So please remember that after obtaining the complete solution, after simplifying all these terms only, we have to expand our e power ax and we have to take real part or imaginary part according to our trigonometric function.